Hi and welcome to another video. Today I would like to have a look into state, but not state management, but the state object itself. When working with Flutter, we usually work with two types of widgets. We work with stateless widgets and with stateful widgets. The stateful widgets is something we usually generate by using our snippets or templates like this. Let's import widgets. Here is our own stateful widgets. The generated code comes with this createState method and with this state class that is extending a state object over here. However, did you ever wonder what the state actually is, how it works, except of course of holding the state itself? In this video, let's have a look into state. First of all, let's go into this state object. Let's see what we have here. On top we can see that it's an abstract class, and then down here we can see that this state object is holding a widget. And this makes sense because we want to be able to access widget inside of our build method, for example. When there are any arguments passed to the widget itself, in our state we would call widget.something. Secondly, we have this state lifecycle. So a state can be in a couple of different states in its lifecycle. If we have a look over here, we have the created state, initialized, ready and defunct. And as we will keep looking how the state is managed by the framework, we will see how these different states are being assigned to it. But here the documentation says you basically a little bit about how it works. So the state created is when the object has been created, and the init state is called at this time. Initialized is after the init state method has been called, but the state object is not yet built. And they also say you that at this time the didChangeDependencies method is being called. After that we get to this state ready, and a state object is ready to build, and dispose has not been called yet. And finally, when we are done with our state, then we are setting dispose on it. Now back to our state class. Here we have another getter, and this getter is context, and this is where you can see what the build context actually is. Down here we have some assertion, and first we check if there is an element. If there is no element, then we throw an error. Otherwise, when we have an element, then we return this element. And the element is specified down here in this field. And in case of a stateful widget, we have a stateful element. And this is why build context is actually an element. Or in other words, every element is extending or implementing the build context interface. Then if we keep going down, we have this mounted getter, which is used, for example, to check whether we can do something in a callback, whether the widget is still there, still available, and we can, for example, set state on it. And you can see that a widget is mounted if it has an element. So if element is null, then we will have a false returned. And that means we are not mounted at this point. Then down here we have our init state method, which we usually override with writing some initialization code for our state. And here you can see we have two annotations. So first of all, the access modifier annotation protected, and secondly we have this must call super annotation, which basically means that you are supposed to call init state super.initState inside of your own implementation of init state. However, you can see that there is not much happening, so here we are only asserting that at this point our lifecycle state is set to created. Then if we scroll down, we have a definition of this didUpdateWidgets method, which we can also implement. We have the reassemble callback. If we scroll further down, we have set state, and into set state we have had a look into one of the previous videos, so I'll skip it for now. Set state basically calls on the element this method mark needs build, and this method then basically sets that this element is set to dirty and it needs to be rebuilt. Then down here we have the deactivate callback, activate callback as well. We have finally dispose. And in case of dispose, again we have only assertions in here. So in case you are overriding the dispose method and you forget to call super.dispose again, in production nothing really will happen over here because asserts are not run in production. But basically these asserts are checking whether we are currently in the state ready, and if we are in the state ready, then we can set over here the state to defunct. So dispose basically means that we are setting the state to defunct on our state. Then if we keep scrolling down, we have a definition of our build method, and this is something we should implement. Notice that this doesn't have a body, so it's ready to be implemented by us. Then we have here this didChangeDependencies callback, and finally something also for debug. And that's it, that's our state object. So being back here in our very simple stateful widget, let's have a look how this state object is handled. And that's basically handled in the stateful widget class. So if we have a look into the stateful widget class, there we go. So a stateful widget is a widget, and it doesn't do much. Widgets have basically two main functions. First function is they're a configuration, so in widgets we define things, how they should look like, how they should be laid out. And secondly, the second function is to create an element. For example, for a stateful widget we have this stateful element, and the only other method that we have in stateful widget is this createState method over here. So we have this method createState over here which returns state. But where is this method called? For that, let's have a look into the stateful element. Okay, here is our stateful element, and here is the constructor. And then here in the constructor you can see that we are calling widget.createState. So widget was passed in the constructor to this element, and then we create state on it, and we save it to this _state variable. Then in the constructor body itself we have some assertion over here for debug, and then we have another assertion, and here we are making sure that state does not have a reference to an element yet. Secondly, if this assertion passed, then we are assigning our current element, this, to state. So state._element, we are assigning this. Then we have another assertion. This time we check that state_widget is equals to null. So we want to make sure that the state doesn't have a widget assigned yet, because we want to ensure that state cannot be reused between two different widgets. And if this assertion is okay, then down here we are assigning the widget that is held by this stateful element to state. And finally we also make sure that currently the debug lifecycle state was set to the value created. In other words, after we went through the creation of the element, its constructor, then the lifecycle state should be set to created on the state. Then inside here we have the build method, so an element has also a build method, and in case of a stateful widget, everything that is done we just call the build method on the state. So this build method is basically the method that you have implemented in your state. If we have a look back, in my case this is this build method that's getting called, and here we have this build context passed, and if we have a look back into how this build method is called, it's basically only this current element that is passed over here. Which means that it doesn't matter whether here you will call this context that was passed as an argument, or you will call this context that is stored in the state itself. Both of these contexts are the same context. Let's scroll down. Then over here we have the instance of the state itself, and then we have this reassemble overridden method, and you can see that here we basically call reassemble on state. Next we have a first build, and this is an important thing over here, because the first time we are building a widget, then we are calling this first build method, and then with every subsequent build we will call another method. We have here this perform build method, for example. However, the first time that this widget or the element gets built, then we are calling the first build. And what happens here, we still make sure that we are still in the state lifecycle created. Then we are running the init state method over here, and we are casting it as dynamic, and we are doing that in order to assert that init state does not return a future. This is basically to ensure that init state cannot be an async method. Then if we go forward, if we pass this step, then we have this another assertion where we basically said that okay, now we run init state over here. Init state was in the future, so we didn't throw. Now we can set that our current state lifecycle is initialized. So we're no longer created, now we're initialized. After initialized, we call this state.didChangeDependencies method, which you can override as well. And after running this method, we are basically setting the state again, this time to ready in this assertion. So from initialized we went to the state ready after the didChangeDependencies was called. Then we also have a perform rebuild, so in case a widget gets to get a rebuild because something changed in it, a dependency changed, then we have a field didChangeDependencies, and if that's set to true, then we call again didChangeDependencies on state. And in case we need to rebuild the widget, then this update method will be called, and a new widget that was built will be passed to it. And over here, first we assert that a current widget is equals to new widget, which means basically that in the element, the widget that is set there already got replaced, and the instance of an old widget was kept in this state. And at this point, we mark this element dirty, so we want this element to be rebuilt. And finally, we assign and we pass it and save it within state. Then over here we also make another check whether the didUpdateWidget method returned a future, and if so, we also want to throw, because the didUpdateWidget method, if you override it, it is also not supposed to be asynchronous. If everything worked fine over here and we didn't throw, then finally we call this rebuild. And the rebuild method defined down here, and at this point we don't want to be in the initial state, remember this was done in the constructor. And then we also don't want to be in the active state right now, or not dirty. If we are not dirty, if we are clean, then we don't want to rebuild. Then we do a little bit more of debug assertions over here, let's skip that. And then down here, we want to make sure that now we are in the active state. And finally, when this is done, then using something called a build owner over here, we are rebuilding this widget or this element. However, this here is for another video. Then here in the stateful element we also have these methods like activate, deactivate, and then inside of this we just call these callbacks on the state object. So if you have overridden the activate or deactivate on state, then this is basically where it gets called by the element. Then we have a very important method which is called Unmount. And over here in the Unmount, what happens is, first we call dispose on state, which is another callback that you can override and dispose your resources. So first on unmounting we are disposing the state. Then again we have an assertion over here and we check whether we are currently in the defunct state, which should happen over here. If we have quick jump over here, you can see that here, as we've seen before, in the assert we are basically setting this debug lifecycle state to defunct. And a possibility that we will not be in the defunct state over here is if you are overriding the dispose method on the state and you don't call the super method on it. And then if it's okay over here, then basically what we do, we say that the element on state should be no longer referenced. And then to just clean everything up and let the garbage collector collect everything and release the memory, as they say over here, we also make sure that the state is not kept inside of the element. So then there is no reference to the state in the element, and the state doesn't have also a reference to element, and everything can get disposed and wiped out of memory. Finally, we have a couple of other methods. So here we are handling the inherited widgets, passing the data through our tree. We have this didChangeDependencies variable that we've seen before that is initially set to false, because initially we built anyway the widget, and the didChangeDependencies will be called. And then we also have some diagnostics and debug method. Then to summarize, a state object is something that we are extending. It's an interface that we are implementing, and then we are creating it within the createState method inside of our stateful widget. This gets passed to the element, and also state gets a reference of an element. Then the element itself is handling the state and calling callbacks on it. And finally, when everything is done and the widget should be disposed, then we break the reference between the element and state, and the memory is wiped and we have state no more. So that's everything that we should know about state. This is more or less a discussion of the state lifecycle in the stateful widget. And I hope this video helped you a little bit to understand what state actually is, how it's handled. If so, please subscribe, give me a like, and I will see you in more videos like this in the future. But for now, I code you to death, and bye bye.